So welcome students. So in this question, you're given an equation x square plus x plus 2 whole square minus of a minus 3 times x square plus x plus 2 into x square plus x plus 1 plus a minus 4 times x square plus x plus 1 whole square is equal to 0. So if this equation has at least one real root, then a belongs to which range? That's the question. So how do we solve this? So first let me try to make this into a standard quadratic equation. So to do that, what I do is I'll divide the whole equation with x square plus x plus 1 whole square. So if I divide the whole equation with x square plus x plus 1 whole square, the equation becomes x square plus x plus 2 by x square plus x plus 1 whole square minus of a minus 3 times x square plus x plus 2 by x square plus x plus 1 plus a minus 4 is equal to 0. So now let us assume that let x square plus x plus 2 by x square plus x plus 1 is equal to t. Now this equation becomes t square minus of a minus 3 into t plus a minus 4 is equal to 0. Now this is a quadratic equation. So this has two roots t1 and t2. Now how do you get the solution of x? So you equate this x square plus x plus 2 by x square plus x plus 1 with t1 ones, you get two solutions, and t2 ones, you get two solutions. So total you can get a maximum of 4 solutions for x. Now according to the question, so this equation should have at least one real x as solution. That means the theory in this question is, so x square plus x plus 2 by x square plus x plus 1 cannot take every value of real numbers. So first I'll find the range of this. I'll find the range in which this expression lies. So if I have to find the range of this can be written as x square plus x plus 1 plus 1 by x square plus x plus 1. This is nothing but 1 plus 1 by x square plus x plus 1. Now this is a quadratic. So we know that x square plus x plus 1, the range of this. How do you find the range of a quadratic expression? So x square plus x plus 1 will always be greater than or equal to minus d by 4a. The least value of this expression is minus d by 4a. That is minus of d is b square minus 4ac minus 3 by 4. That means this expression is always greater than or equal to 3 by 4. So this expression lies between 3 by 4 and infinity. So this implies 1 by x square plus x plus 1. So if I reciprocate this, this will be, so this signs will get reversed. So this becomes less than or equal to, this becomes less than. So 1 by infinity is 0 and this becomes 4 by 3. So 1 by x square plus x plus 1 is always lying between 0 and 4 by 3. So if I add 1 on both sides, so 1 plus 1 by x square plus x plus 1 will be lying between 1 and 4 by 3 plus 1 is 7 by 3. So this expression always lies between 1 and 7 by 3. That means the range of this is open 1 to close at 7 by 3. So if this equation has to have a real solution, then this equation should get at least one root in this range. So if both these t's lies outside this range, you won't get any solution for x. So if you want some solution for x, one of these roots, so you don't need all real solutions. So if you want at least one real solution, one of these t1 and t2 has to lie in this range. That is 1 to 7 by 3. At least one of the solution should lie in this range. So what should be the values of a, which ensures that at least one solution lies in this interval. So you can have both the solutions in this interval or at least one. So now, so how do you ensure at least one of the roots lies between 1 and 7 by 3? So our equation is t square minus of a minus 3 times t plus a minus 4 is equal to 0. So one thing that is clear from this equation is that t is equal to 1 is always a solution. So you can substitute and see t equal to 1 minus of a minus 3 plus a minus 4 is always equal to 0. Minus a plus a gets cancelled, 4 minus 4 gets cancelled. So t is equal to 1 is always a solution, which you don't want, because for t is equal to 1 you don't have any real solution to x. Now at the other solution which you have, the second solution should be less than 7 by 3. The second solution has to be less than 7 by 3. So if 1 is a solution, the graph can look like this. The other solution might lie before 1, or the graph might lie like this. The other solution might lie after 7 by 3, or the graph might lie something like this, where one root comes between 1 and 7 by 3. So this is the case that I want. At least one root has to lie between 1 and 7 by 3. So how do we ensure at least we have this? So first is f of 7 by 3 has to be positive, and the x-coordinate of the vertex has to be greater than 1. These are the two conditions that you have. The conditions that we need to ensure is discriminant is greater than or equal to 0. This is a general condition for real roots, and minus b by 2a should be strictly greater than 1. Minus b by 2a has to be greater than 1, and f of 7 by 3 has to be greater than or equal to 0, because 7 by 3 is also okay. So to solve the first condition, discriminant is greater than 0, a minus 3 whole square minus 4 times a minus 4 is greater than or equal to 0. So if you solve this, you get a square minus 6a minus 4a minus 10a, a square minus 10a plus 9 plus 16 plus 25 is greater than or equal to 0. This implies a minus 5 whole square is greater than or equal to 0, which is always valid. This is always valid. In the second case, minus b by 2a, that is a minus 3, b is minus of a minus 3, minus b is a minus 3 by 2 is greater than 1. So a is greater than 5. So a minus 3 is greater than 2, a is greater than 5. And the third condition is that f of 7 by 3 is greater than or equal to 0. That is, if you put 7 by 3, have 49 by 9 minus 7 by 3 times a minus 3 plus a minus 4 is greater than or equal to 0. So if you take LCM, you get 49 minus 21 times a minus 3 plus 9 times a minus 4 is greater than or equal to 0. This implies 49 plus 63 minus 36. So you have 49 plus 63 minus 36, that is 76. Minus 21a plus 9a minus 12a is greater than or equal to 0. So 12a is less than or equal to 76, a less than or equal to 76 by 12, that is a less than or equal to 19 by 3. So a has to be greater than 5 and a has to be less than or equal to 19 by 3. So the range in which a has to lie is open 5 to closed 19 by 3. So that will be the value in which a has to lie, so that at least one of the solution of t lies between 1 and 7 by 3, which further ensures that at least one of this equation, at least one root of this equation is real. Thank you.